Okay, so let's do a couple of warm-up problems, and then we'll get on to the new topic. I've got f prime is 9x cubed plus the sine of 5x plus 6 times the square root of x, and I wish to find f. What are you going to do with the 9?
9 over 4.
Coming with, and then x to the 4th over 4. Very good. Minus the cosine of 5x over 5 plus 6 x to the 3/2, very good, multiplied by 2/3, and then plus c. Simplifying isn't necessary here. We're just trying to learn the process. One thing I would recommend, get the exponent first, right? Find the exponent, because the reciprocal of the exponent is a required component. So get that exponent figured out first. All right, let's try one more practice problem. F prime is 5 over x cubed plus secant squared 5x plus 9 times the 5th root of x. X to the -2, so times -1/2. The antiderivative of secant squared would be tangent. What's the argument going to be?
5x
So over 5. The 9 is coming with. The current exponent is 1/5. X to the 6/5 times 5 over 6 plus c. Okay. So that's just something you'll get better and better at as the semester goes on. Okay. So now we run into something called an initial value problem. How many functions are there that have 9x squared minus 4x plus 5 as their derivative?
One.
An infinite number of them. Yeah.
Yes,
has that as
There's an infinite number of different functions that have that derivative. All of them are a cubic, but the plus c might be plus 1, plus 2, plus 3, plus 4. That vertical shift at the end doesn't change the function, or doesn't change the derivative. Now, there's an infinite number of different functions that have this derivative, but only one of them has that characteristic. And what it says here is, when the x-coordinate is -1, the y-coordinate is 0. Only one of them passes through the point -1, 0. My question is, or my goal is, find that function. So what they're giving me is one point to work with. That'll narrow it down from an infinite number of antiderivatives to 1.
Is the 5 the c in that
No, we will add the plus c in and then solve for it. So, if I take the antiderivative of dy dx, that's going to be y. What's the antiderivative of 9x squared? 3x cubed. And then the antiderivative of -4x? Minus 2x squared plus 5x, and then plus c. Now, as I look at the equation on the board, I've got variable y, variable x, and variable c. And that c is a vertical shift of this cubic. It could be up or down depending on the value of c. I want to find the one cubic that passes through -1, 0. How am I going to accomplish that?
Make x equal -1 and y equals 0.
Make x equal -1 and y equals 0. So if x is -1, y is 0, we get 0 equals -3 minus 2 minus 5 plus c. So 0 equals -10 plus c, and c turns out to be 10. 10, thank you. C turns out to be 10. Okay, so now one big note here. I'm not done. I haven't answered the question. Now I'm done. Question wasn't find C, it was solve the initial value problem. It's asking me for the actual function.
So say C came out to equal 0. In the initial problem, would you have to write the plus 0 at the end, or could you
Nope.
just leave it?
Technically I'm not wrong. If I leave this as plus C, and down here I claim C is 10, but, you know what I mean? Because that's a legal substitution. But the idea is that we're going to make that substitution. So they would, but well, I'll tell you what it's going to show up. It's going to show up in a multiple choice question where they're not going to have plus C in their answer. Okay, so here's another similar question. This time it's telling me the second derivative is the linear curve y equals 10x. They're giving me a fact that the graph contains the point 310 and 310 is a minimum. We also know that it's a continuous differentiable graph, and we wish to find the curve that has all of these characteristics. Now think backwards for a minute. If the second derivative is linear, the first derivative is
Square.
quadratic. And if the first derivative is quadratic, the curve itself must be cubic. So we're out here looking for a cubic, and what we're going to have to do is 2 repetitions of the process. Okay, so the first thing I know is that the graph contains the point 310. What it's saying is when x is 3, y is 10. It also says 310 is a minimum. So when x is 3, y prime is 0. Okay, so let's go to work. What is the antiderivative? Here's what I've got. Y double prime is 10x. I'm going to integrate this. The antiderivative of y double prime is y prime. And the antiderivative of 10x would be
5x squared. Plus C.
plus C. Correct? Now up above, what we said was when x is equal to 0, no, when x is equal to 3, y prime would be 0. So we first find C by substitution again. 0 has to equal 5 times 3 squared plus C.
Why is y prime 0?
Because we're talking about a cubic in this problem, and 310 is a minimum. Well, if you've got a minimum on a cubic, it's going to have a horizontal tangent. So what do we end up with here? C is negative 45. Now, we have to repeat the process, so we go with y prime is 5x squared minus 45. My goal was not to find y prime. My goal is to find the original function y. So we integrate yet again. And the antiderivative of y prime is y equals, now let's work left to right, 5/3 x cubed minus 45x plus c. And now when x is 3, y has to be 10, isn't it? That's what we had up earlier.
Oh,
X is 3, y is 10. So 10 has to be 5/3 of 3 cubed minus 45 times 3 plus some constant. 27/3 would be 9. 9 times 5 is 45. 45 times 3 is 35. So minus 135 plus C. 10 has to equal negative 90 plus C. C turns out to be 100.
And then on the test it's going to be 105.
So here is the curve I ended up finding. 5/3 x cubed minus 45x plus 100. That's not so terribly hard, is it? Not at all. As long as you got through yesterday's homework and you practiced your skills of finding antiderivatives, this won't be bad. Okay. Ugh. 3 times. Now, I got to tell you, this problem is often widely misinterpreted. Tell me about the third derivative. All lines are straight. It's a horizontal line. Now, if the third derivative is a horizontal line, tell me about the second derivative. Also going to be linear, isn't it? Linear with the slope of 10. Now, if the second derivative is linear, the first derivative is quadratic, and the function that started here is cubic. What happens is people see that the third derivative is a horizontal line, and then they're confused because it also says the second derivative is a horizontal line. Does it actually say that? No. These are values right here. It says the second derivative turns out to be -3, but only when x is 0. So these are those initial values along the way that we're going to use to solve the successive values of c. Okay, so if we take this thing, here's what it says. When x equals 0, y is 5. When x equals 0, y prime is 12. When x equals 0, y turns out to be, y double prime turns out to be -3. So I'm going to have to solve for c 3 different times along the way here. So we start here with y triple prime is equal to 10. Therefore, y double prime is 10x plus c, and then we use this initial condition because we're looking for c using y double prime. So when x equals 0, y double prime has to be -3. 10 times 0 plus some constant is -3. In this case, the constant is 3. Let's go back to work. The antiderivative of y double prime is prime 5x squared minus 3x plus a constant. Now we go to this condition. 12 has to equal 5 times 0 squared minus 3 times 0 plus some constant, and that constant is 12. I was going to say, I think you'll learn to like it when x is 0. And finally, we repeat one last time. The antiderivative of y prime becomes y equals 5 over 2, 5 over 3, x to the third, minus 3 over 2x squared, plus, and then finally, plus c. And now I resort to the last of these conditions, just a minute. 5/3 of 0 minus 3/2 of 0 plus 12 times 0 plus this constant has to equal 5. What does that constant turn out to be?
5.
Andrea.
On the y double prime, how did we get 10x minus 3? Like, where did the minus 3 come from?
Well, the antiderivative of 10 was 10x plus c, and then we used this initial condition.
Oh, okay.
All right? Okay, one thing. Daniel made a really nice observation. I like it when x is 0. But do keep in mind, not every function takes 0 and leaves it 0. Most notably, e to the 0 is 1, and cosine of 0 is 1. So don't automatically assume that when you're given an initial condition and x is 0, that it's going to be really simple to pick out those constants. Sometimes the function is more complex than what we have here, and you actually have to do the substitutions. Okay, so this should be sort of an aha moment for you. you'll learn something significant here. A rock is thrown upward with an initial velocity of 160 feet from a height of 120 feet. Find the velocity of the rock as it strikes the ground. We're talking about feet. Tell me the acceleration due to gravity when recorded in feet. Feet. All right, well, I'll tell you then. Negative 32 feet per second squared. What's that? Yeah, you wait. Okay, now here's what it says in the problem. It says a rock is thrown upward with an initial velocity of 160 feet. When time equals 0, the velocity is 160 feet per second. It also says when time equals 0, the position is 120. If I apply my technique here, I can actually create the function that tells me the height at any given time. The antiderivative of acceleration is often referred to as velocity equals negative 32t plus c. When time is 0, the velocity has to be 160. This c is 160. Now, we're going to use a sentence that's not technically true here, but just bear with me. We're going to integrate both of these. The antiderivative of velocity is position. That's not technically true, but it's close enough to true that we're going to use it. Position is negative 16t squared plus 160t plus c. When time is 0, the position has to be 120. What is this constant? It's that one equation. You might remember it from pre-calculus that said the position at any given time is negative 16t squared plus v0t plus s0. Now, this negative 16 actually is negative 1/2 gravity, isn't it? That work is the number 4.9 familiar to you guys that are always working with 9.8? Yeah. How come? Because that's half g. So that should kind of, for you people in physics especially, that should kind of serve as an aha moment, especially the velocity being negative 32t plus 160.
Wait, don't you need a plus c? It's 160 to c.
No, I erased them along the way. I went through 2 iterations.
Oh,
in this
so you
process.
didn't need c in this?
I did. The first time I got the 160, and the second time I got 120.
For c?
Mm-hmm. It's true, I did.
He just had it erased.
I had it and I erased it. So now we can answer the question. The question is, find the velocity of the rock when it strikes the ground. Well, we have the velocity function. The velocity function is negative 32t plus 160. So if I want to find the velocity, what I really want to know is, when does it strike the ground? If I can find the time at which it strikes the ground, I can calculate that velocity. Well, what shape is this? Opening with a y-intercept at 120. If I draw this, I'm going to get a picture that looks like this. And there's going to be a root over here. And that root is going to have an x-coordinate. The y-coordinate is going to be 0. And that y-coordinate stands for the height. So what I really want to know is, when does it strike the ground? If I can calculate when it strikes the ground, then it's as simple as plugging that value in here. So find it for me. When does it strike the ground? We're simply looking for the positive root of that quadratic formula.
$10.00.
10 seconds?
10.70.
10.7?
Yes.
So now I want to know what's the velocity when it strikes the ground. Well, I now know when it strikes the ground. So the velocity at 10.7 is negative 32 times 10.7 plus 160, which hopefully turns out to be a negative number since the object was traveling down when it hit the ground. Mary, was that a question?
Yeah.
Go ahead.
But it was from the one in our packet.
Mm-hmm.
I don't understand if they didn't give us the, how do we do?
Okay, the one in your packet is asking you to find the formula in general. The one in your packet is telling you the following. We know the acceleration due to gravity is negative 32. Then they're telling you when time equals 0, the position is going to be called S0. And when time equals 0, the velocity is going to be called V0. So as you go through this process, you're going to get V is equal to negative 32t plus some constant. Now, when I use this, I have V0 has to equal negative 32 times 0 plus c. What does c turn out to be in this case? C turns out to equal V0, so we change this to V0, the initial velocity, and then we
So it's really just that simple.
repeat the process. Yeah, they're just asking you to derive the general formula by using variables instead of numbers. Okay. So with what velocity do you enter the water if you step off of a 100-foot platform? Step off. You're not diving off, you're just going to step off the So, we're measuring in feet again, so what are we going to use for gravity?
Negative 32.
Acceleration is negative 32. At time 0, what's your height? 100. And at time 0, what's your velocity? 0. You're not moving, right? You're standing on the platform. There's nothing happening. You're going to start falling. Antiderivative of acceleration will be called velocity. Turns out to be negative 32t plus c. Now, when time is 0, the velocity has to be 0. So 0 has to be negative 32 times 0 plus the constant of integration. In this case, the constant is 0. Okay? Now we repeat. We will call the antiderivative of velocity position. It's not technically true, but it is close enough for our arguments right now. Negative 16t squared plus the new constant of integration. Wait a minute. I've got an error here, don't I? 100 has to be negative 16 times 0 squared plus the constant of integration. Thus, the second constant of integration is 100. Again, the question is, find the velocity. So we're going to use V of t is negative 32t. But the real question is, how long does it take you to hit the water? Because if I can figure out how long it takes, then I've got a way to calculate the velocity. What do I need right here? 0. When I hit the water, my position is now 0. So if 0 is negative 16 t squared plus 100, 16 t squared is 100. T squared is 100 over 16. Of course, there should be a plus minus in here, but I'm not going back in time. No. T turns out to be 10/4, 2.5 seconds. So your velocity at this time is negative 32 times 10/4, or negative 80, and that would be feet per second. Keeping in mind that 88 feet per second is 60 miles an hour.
Jeez, you're dead.
So, well, no, you're going to hit water. If you enter correctly, you'll be okay. Don't do a belly flop. Right. Yes, point your toes. Don't belly flop. Okay, now we're going to close it off today with my favorite trick question of this part of the book. I have marked this question wrong on the test so often that I've actually rewritten the question. A rocket lifts off from Earth with a constant acceleration of 30 meters per second squared. How fast is the rocket traveling 2 minutes later? This is a velocity question. How fast? Velocity. And here's where it goes wrong. What are you going to use for A? No, this rocket has 30. This rocket. So when I wrote the test question, I actually changed it and wrote, a rocket overcomes gravity and has an acceleration of 30 meters per second. Because it's so common for people to give this rocket negative acceleration. Negative acceleration, and it's going up, means that it's actually slowing down on the way up, right? That can't happen. So, if the rocket lifts off with an acceleration of 30, what's your velocity going to be? 30t plus c. Well, what was the velocity as it sat on the launch pad? 0. So there's my velocity. Still, there's another trap going on here. I want to know the velocity 2 minutes later. Yes, it is a trap. Yeah. The acceleration is being measured in meters per second squared, so this 2 minutes has to equal 120 seconds. I know, 30 times 120 turns out to be 3,600 meters per second. So there's two traps there. We get sucked into thinking acceleration is always negative 32, but that's not the case. This rocket has a motor. It's not a projectile. And then the second thing is you have to use the correct units. Add.
How did you get c equals 0?
Well, we knew that at time 0, this rocket was still sitting on the launch pad, so it had no velocity. So when I solved the initial condition here for plus c, 0 went in for time, and 0 went in for velocity, and so 0 equals 0 plus some constant. That constant has to be 0.
Is c always equal to the initial velocity?
In this case, it will. All right, so for tomorrow, you've got 19 of these to attempt. Good luck. They're not as easy as yesterday.